Next, let us talk about the water reticulation plans. This is another plans that you need to produce while doing the integrated design project. What is water reticulation plan? It deals with the water supply, which is being distributed to the developed areas, supplying waters to every single units of the buildings for the daily usage of the occupants of the buildings. Now, when we talk about the water supply, there are two systems that we are referring to. One is the water reticulation system. Another one, it will be the internal plumbing system. The water reticulation systems is designed by engineers. As the outcome, water reticulation plans is produced. As for the internal plumbing systems, it is produced by the architect. As an outcome, schematic drawings for the internal plumbing systems is produced. Now, as far as civil engineer is concerned, we deal with the water reticulation plans. What about the water reticulation plans? The main focus here is to connect the pipes, which is known as the mains, to every single units of building, ensuring the sufficient pressures in the pipes so that the water can flow within the pipe, reaching the occupants of the buildings. We will need to calculate the head loss due to the frictions in the pipe, and we will need to ensure that the pressure in the pipes is adequate, not too low that prevent the flow of water, and not too high that may burst the piping systems. And then in the water reticulation plans, we will need to demonstrate the layout of the pipe network, as well as providing details for the constructions of the water reticulation systems. This is an example of the water reticulation system. The water reticulation systems is worked on basis of the engineering plan. Normally, once we have confirmed the engineering plan, removing the details of the engineering plan, such as hatching, symbols, and whichever irrelevant to the water reticulation systems, then we demonstrate the proposed piping network over the plans. Why do we need to refer to the engineering plan? Because in the engineering plan, there are culverts proposed. In the existence of the culvert, the water mains will have to go over the culvert. That leads to the mains systems, not in the same elevations. There may be traps of air bubbles in the pipe. The air bubbles in the pipes will disrupt the flow of the water in the pipe, and this can affect the functionality of the piping systems. Now, taking this plan as an example, you will first read the legends. There are two groups of components here: the existing and the proposed. As this development is an extension to the existing development here. Normally, before we propose for the water reticulation system, we need to have an idea on the existing main systems in order to determine where are the intakes of the water, where to tie in the proposed mains so that the water can reach to the developed areas. Let us first look at the existing water reticulation system available. We have 150 mm diameter DI pipe. DI stands for the ductile iron. That means the existing mains are made of 150 mm diameter ductile iron pipe. We have pillar fire hydrant. This is needed in the case of any fire hazard, where the firefighter can connect and acquire waters in order to put out the fire. We have sluice valve. It is used to control the flow of water through straight pipes and ask the shut-off valve to isolate the water supply. You will need this switch valve for the maintenance purpose. In case that any leakage of the water mains, the relevant switch valve can be shut off so that the maintenance work can be carried out. We also have the air valve. This is to release the air from the piping systems so that the air are not trapped in the piping system that can disturb the flow of the water in the pipe. And then there are culverts. Taking this project as an example, this is the existing project, and the lines here represent the water reticulation systems. As indicated by the symbols, we have fire hydrant, sluice valve. There is a culvert here. That means the water mains here passing through the culvert will have to go over the culvert. Now there will be a change of elevations as the pipe crosses the culvert. You know that air bubbles are always heading outward. This may lead to a situation that airs are trapped on top of the pipes. Over the time, air may be accumulated at the region. Therefore, you will need air valve to release the air bubbles. And then you see the water main crossing the road, fire hydrants, air valve, switch valve, and others. What you can see here, there are some simple rules of thumb. Normally, there will be switch valve at the junctions of the water reticulation system. They are strategically placed at the junctions, which indicates that any parts of the water reticulation systems require maintenance. The nearby switch valves can be turned off in order to minimize the impacts in terms of the disturbance of the water supply to the units of the other regions. This is about simple principles of adopting the switch valve. The air valve normally comes when there is a change of elevations in terms of the water mains. That's why you will see whenever passing through the culverts, there will be one air valve. As for the fire hydrants, there is a requirement in terms of the maximum distance. We are talking about clear distance between the fire hydrants. This will need to be strategically placed so that in case of the fire hazard, the firefighters can access the fire hydrant in order to acquire the water supply reaching to the affected units. Based on the requirement for the typical residential areas, the clear distance should be around 90 meters. In another word, the coverage of the radius distance, it will be about 45 meters. Although it is stated that the radius distance is about 45 meters, but we are still looking at the clear distance. Imagine this unit is under fire. The nearest fire hydrant, if it is located here, then you have to quantify the clear distance here, whether it is within the 45 meters. If this is not reachable by this fire hydrant, you will need to make sure that there is another fire hydrant that is reachable. Even though the radius distance here is less than 45 meters. You need to imagine it is nearly impossible for the water pipes from the fire engines to pass through here, passing through the building units, reaching this unit here. Therefore, when we are quantifying the clear distance between the fire hydrants, we are talking about the access distance, not more than 90 meters. Next thing about the fire hydrant is that normally we will need fire hydrants to be at the end of the water reticulation systems. This is the existing areas. During the development of these existing areas, this is a void. This area is not developed yet. Now you can imagine the water reticulation system will end here. Now at the end of each water main system here, you will need a fire hydrant. Why is this so? It is because there may be sedimentations at the end of the water reticulation systems. You can take advantage of the fire hydrant here in order to flush out the sedimentations within the pipe. One more thing about the layout of the water mains. Normally they are placed in front of the building units. Have you ever wondered, for 2 rows building here, wouldn't it be more economical if you provide the mains at the back of the buildings? Instead of having 2 mains here servicing 2 rows of building, why not you just provide 1 mains here servicing both rows of buildings? There are 2 reasons for this. Mains are provided to supply waters into the building. There will be pipes connecting the buildings from the mains. Before the water enters the buildings, the water will pass through a water meter. The water meters is used to quantify the amount of water used by the building occupants. Now, the water supply agencies will need to record the consumption rate of the water so that the building owners may be charged accordingly. That is the first reason. You will need to allow access of the operators recording the water meters on the monthly basis. That's why you put the water mains in front. Putting the water mains at the back of the building will disturb their access to the water meters. Another reason here is due to the firefighting purposes and the access of the fire hydrant. The firefighting engine is relatively large and bulky. You need to allow the access of the fire engines to the fire hydrant to put out the fires in case of the fire hazard. Now, by looking at the layout of the water reticulation system here, can you tell there is a mistake in terms of the proposed layout? Something is wrong with the layout. These buildings cannot access the water main. Theoretically, there should be another water mains here. There are 2 ways to do it. Either by having a water main system here, or you can have a loop in terms of the water main system. This is to allow this building here can access to the water main. This is how it looks like when you are having a loop in terms of the water main system. Now, what makes the difference between having the loop here and having an individual water reticulation system here? The independent water reticulation system here will have to be of equivalent size of the others. Whereas, if you are using a loop system here, you can choose with a smaller size main, and sharing the waters can be supplied into those units. These are some considerations related to the water reticulation systems. Also, if you observe the existing water reticulation system, assuming this area is not developed yet, the development ends here towards the lot boundary. Since your intentions of having the water reticulation systems is to supply to every single units of the building, by right, you don't have to end your water reticulation systems to the boundary of your lot. As long as you can ensure the water mains can reach to the last building here, theoretically you can end your water reticulation system here instead of ending here. Same goes to this side and also this side. You can actually choose to end here and also to end here in order to minimize the construction costs. However, it doesn't work this way in the reality. Ultimately, after the development, the developer will have to hand over the water reticulation systems to the water supply agency without any cost. There will be a defect liability period of 12 months. Once it is handed over to the water supply agencies, now this water reticulation systems, it will be fully under the responsibility of the water supply agency. As far as the developer of this piece of land is concerned, his word is done. However, there may be development in the adjacent lot. Now, theoretically, when it comes to the development of the adjacent areas, no development is allowed outside the lot boundary. Now, if you do not have the water reticulation systems reaching to the boundary of the lot, there will be trouble tapping the water reticulation systems with the existing mains. That's why normally during the submissions, the water supply agency will require the developer to have the water mains ends at the lot boundary so that future development can easily tap the waters from the existing mains. Now that we have done with the existing water reticulation system, let us look at the proposed water reticulation system for this particular project. The existing mains use the DI pipe, the ductile iron pipe. Now the new development here use the HDPE pipe. HDPE stands for high density polyethylene. That means the pipe is made of polymers. There are two sizes here, 160 mm diameter and also 63 mm diameter. The main water mains are using the 160 mm diameter. As for the looping water mains, since the servicing areas is limited, smaller diameters may be used. Now you will need to make sure that the water reticulations manage to achieve every single unit of the new development. Again, what you see here, normally the water reticulation systems will have to end at the lot boundary as given here, here and also here. We have the switch valve which is placed at the junctions or the potential junction. You never know. In future, this development area may need to tap the water here. Therefore, in this case, probably you will need a switch valve in the junction here. You may also require the switch valve here, or probably here and here. These switch valves need to be strategically placed so that you can compartmentalize the service areas. In the case that there are requirements for the maintenance minimum numbers of buildings will have the water supply disrupted. And then we have pillar fire hydrant. You will need the pillar fire hydrant at the end of the water mains in order to remove the sedimentations. From time to time, for this fire hydrant, you can also choose to have it end here. And then you will need to plan the locations of the fire hydrant to have the clear distance of maximum 90 meters between one and another. This is for the access of the firefighters. This provides an overview and basic concept of the water reticulation system.